Hi, my name is Mark Janung. I'm the Vice President of Flight Operations for Iris Automation. And I'm proud to lead the 8 pilots on my team that daily test our Casia detect and avoid technology. We operate a fleet of unmanned drones, including fixed-wing, multi-rotor, and VTOL aircraft to simulate the kinds of fleets that our customers use. And what we do on a daily basis in the field is that we test our Casia detect and avoid technology against manned aircraft, again flown by my pilots. We own our own general aviation aircraft, and 2 of my pilots are commercially rated pilots, and frankly half of our team are also private pilots. So we have a tremendous amount of aviation heritage here at Iris. And so what we typically do on a daily basis is that we'll come together as a team, pack, do a set of pre-briefings, transit out to our test site, pre-flight our drones, and then our general aviation aircraft checks in on site, and he gives me a safety briefing. And then when we're ready, we have the 2 aircraft fly in near collision intercepts with appropriate both vertical and, if you will, lateral separation to cause the Casia onboard system to be able to detect the aircraft, even recognize different kinds of aircraft under different kinds of lighting schemes, and then when we have the system in full auto, demonstrate or prove or validate that the Casia system will cause the onboard autopilot to do an avoidance maneuver to allow that generation aircraft to be able to fly almost unrestricted in national airspace without fear of concern of a collision with that drone. To date, we've done something on the order of about 14,000 such intercepts in the last 2.5 years that I've been part of the team. And I'm very, very proud of our efforts to ensure that Casia can unlock the skies for the safety of drones and the rest of the members of the flying public. Hi, I'd like to do an overview of the Casia 360 system hardware and its capabilities. The Casia 360 system consists of 5 black and white cameras that are placed strategically around the periphery of the aircraft. Each camera has a field of view of approximately 80 degrees and a horizontal, thus allowing a full 360-degree field of view around the aircraft itself. Each camera is connected to a single graphical processing unit, and that GPU processes the incoming video to recognize a set of pixels that are associated with, say, another manned aircraft. And when it sees that and recognizes it as such, it then starts processing to understand whether or not a risk of collision exists or not. And if it does, the GPU then tells the onboard autopilot to do a collision avoidance maneuver. And this maneuver is done in sufficient time to ensure that both the drone and the aircraft remain safe throughout that entire flight. And this is extraordinarily important because now we allow the drones to be able to fly beyond visual line of sight. The design of our system is such that this processing, this automated processing, can occur without any overt action by the ground control station operator. Casia 360 consists of 5 such cameras. The cameras consist of a lens that's enabled to allow it to capture the image, camera body, associated power supply, and a signal which goes to the graphical processing unit. This is the heart of Casia. It's the graphical processing unit based upon the Xavier GPU that takes power supplies and the signal inputs from the 5 Casia cameras to interpret the world and recognize when it sees an oncoming aircraft. The system uses Casia's firmware and software to develop an understanding of the outside world. And when it recognizes the risk of collision exists, it then tells the onboard autopilot to do an avoidance maneuver to protect both the oncoming aircraft and the drone. Several times you've heard me refer to the Casia system interacting with the autopilot. So this is a typical Pixhawk autopilot shown in the body of one of our typical test aircraft. This is what's responsible for the safe operation of the drone. That is, it tracks all the kinematics and allows the aircraft to fly from point A to point B. Casia does not control the aircraft. Well, what it does is it senses the environment and tells the onboard autopilot to do an avoidance maneuver to allow for those two aircraft to pass each other. We currently interoperate with Pixhawk autopilots, flying with PX4, Ardu plane, and Ardu copter firmwares, and we also have been testing and we work with great customers operating with the Piccolo autopilot. So flight days for the flight operations team start early, and we typically assemble in the early morning hours at or near sunrise, get our equipment inventoried and packed, and then once we do one last final safety check of all the trailers and vehicles, we then depart for a test site. The test site we've chosen is in a steer location out in the middle of the desert. This is perfect because we're less likely to have any encounters with other people. We're in Class G airspace, so we're less likely to have any encounters with other aircraft. And it gives us a great location to test our technology without those kind of stressors. Prior to every set of flight operations, we assemble and do a series of pre-flight checks of our aircraft. Because we operate a variety of aircraft, both multi-rotor and fixed wing, our pilots have to be capable of flying all of them and safely employ them in a manner consistent with how our customers would use them in a similar environment. Again, being on a steer location, it does mean that we also operate in relatively hot environments. In this picture, we can see the team is preparing to launch their latest aircraft in our inventory, the X-Axon M14 Viper. This aircraft configuration has the Casia 360 system on board. It has 5 cameras. Each camera has a field of view of approximately 80 degrees. And so that allows us to install these cameras with proper overlap of each other and still ensure a full 360 degree field of view around this aircraft. And this is really important to ensure that regardless of the incident angle of the potential encounter of an aircraft, it will be seen by our Casia system. This aircraft is a wonderful aircraft because it can fly upwards of about 10 hours and is equipped with a gasoline engine. We're now about to observe one of our pilots, Greg, launch the M14. He is in communications with the mission commander and the ground control station operator. And upon completion of all pre-flight checks, we then accelerate the aircraft, and once we reach a flying speed of approximately 45 miles an hour, the pilot will then rotate and launch the aircraft in the same manner as he were a pilot on board the aircraft. In fact, Greg there is a multi-engine commercially rated pilot. Once the aircraft is safely aloft, we'll put it in autonomous flight mode and we'll fly it to our intended test site. In this case, again, over a desert area here in northern Nevada. In this view, you can see that the ground control station operator has already pre-programmed a flight route that we intend to fly the aircraft, and the aircraft is doing that autonomously. All the while, Casia is independently looking at the horizon 360 degrees with the 5 cameras and assessing whether or not there are any other aircraft in the area. The dynamic tracker looks at each one of those videos separately to assess if there's another aircraft. We use that mound, the dark object you see to the left center of the field of view, as a reference point for our general aviation aircraft, as when they fly these near-intercept geometries. We'll use both vertical and lateral separation to safely ensure the aircraft pass safely when proximate to each other, but yet ensure that the Casia system believes the risk of collision exists to cause a collision avoidance maneuver. In this view, we see an oncoming aircraft from the right. In orange, there's the M14 going in the opposite direction toward the oncoming aircraft. and the Casia system is now assessing. Note that none of these images are being projected to the ground control station operator. All this processing is occurring on board the aircraft. And look, it sees an oncoming aircraft. And when it does that, it causes the onboard autopilot to do an avoidance maneuver, in this case to make a right-hand turn and eventually do a descending spiral. Here's a live camera we put on just to give you a better sense. And you see the oncoming aircraft and the drone doing an avoidance maneuver prior to the closest point of approach to safely allow the general aviation aircraft to continue on its mission, and while the drone in a manner consistent with Part 107 yields right away. And in this case, we're doing a right-hand descending spiral. And Ryan has flown this X-Cub for a number of months with this, but he is in a variety of aircraft done something over in excess of 14,000 intercepts against drones equipped with Casia system. And that's what gives us a great amount of confidence of how well our system works. And then upon every completion of every mission comes the best part, the landing. So you can see our drone is coming in for a landing at a dry lake bed, and this is all being manually flown in the end game. And you can barely feel the landing. So again, every mission starts with a launch, and now with the recovery. So this morning we just completed a series of intercepts where we fly our general aviation aircraft in a very carefully controlled set of intercept geometries against our drone that is carrying the Casia detect and avoid technology. During each of these intercepts, we observed the drone do an appropriate evasion maneuver, and we then reset the drone to set up to do another run. So this morning we did approximately 50 runs, which is a great day for us, and is how we've been able to generate over 14,000 intercepts over the last 2 years.